The problem on finding the z transform of x of n is equal to modulus of n a to the power of modulus of n where a is less than 1 using property. Okay, here this is the both-sided sequence. Let us express this x of n as x of n is equal to modulus of n is, it is negative when n is negative and it is positive when n is positive here. Okay, this is first when n is positive, this is n into a to the power of n into u of n, that is the right sided sequence we'll get when n is positive. When n is negative, it will become minus n a to the power of minus n into u of minus n will get. Okay, this is at the left hand side, this is at the right hand side. This is the first step we need to do when you have modulus of n. Okay, that is when for negative sequence, modulus of n will become minus n. Okay, negative sequence is represented as u of minus n, whereas a positive sequence is represented as u of n. Okay, now we can solve this problem using the properties. Okay, first let us take this part as x1 of n. Okay, now let us try to express this in terms of x1 of n. Okay. That is, this part can be expressed as total, this part I'll take it as an x2 of n. Okay. Now we can write this one as x of n is equal to x1 of n plus x2 of n, including minus sign I taken it as an x2 of n. Then what is x2 of n here? That is x2 of n is equal to minus n a to the power of minus n into u of minus n. Okay. This is nothing but x2 of n is equal to, this is x1 of n, we can write this as x1 of minus n, because x1 of n is n into a to the power of n into u of n. When I replace n by minus n in this, you'll get minus n a to the power of minus n u of minus n. I'll get the x2 of n. Hence x2 of n is equal to, what will get x1 of minus n. Okay, that is, what is x of z now? X of z is equal to, using linearity property, I can write that x1 of z plus x2 of z. What is x2 of z here is, x2 of z is equal to x1 of, using time reversal property, I can write x1 of minus n as x1 of 1 by z. That is using time reversal property. Using time reversal property. Using time reversal property. Okay, first let us find out what is x1 of z. What is x1 of, that is x1 of n is equal to, we have n into a to the power of n into u of n. Again, we should get the x1 of z using the differentiation and z domain property. Let me take this part as an x3 of n. Okay, now we'll get, that is x1 of n is equal to n into x3 of n. Then x1 of z is equal to, you will get, using differentiation in z domain property, minus z into differentiation of x3 of z with respect to dz. What is x3 of z here? x3 of z is equal to summation of n tends from 0 to infinity a to the power of n into z to the power of minus n. This is something that is summation of n tends from 0 to infinity a z inverse its whole to the power of n. This is nothing but 1 divided by 1 minus a z inverse, where that is a z inverse is less than 1, that is a by z is less than 1 and z is greater than a. Okay, this is the x3 of, this is the x3 of z. Then to differentiate this, I need to express this in terms of positive power of z. You can write this as a z divided by z minus a. Take this as 1 by z. Let's take z as LCM and it will become z divided by z minus a. From this I can find out what is x1 of z. Okay, x1 of z is equal to minus z differentiation of x3 of z. What is x3 of z here? Is z divided by z minus a. You will get that is x1 of z is equal to minus z. This is nothing but that is z minus a its whole square, z minus a into differentiation of numerator is 1 minus denominator, and differentiation of numerator and differentiation of denominator is 1. You get that is, that will become x1 of z is equal to, you have minus z, z minus a minus z, it will become z by divided by z minus a whole square. This terms get cancelled. Answer is a z divided by z minus a its whole square. This is the x1 of z, a z divided by z minus a its whole square. We can write this one as a z divided by, if we take z common, it will become z square, 1 minus a z inverse its whole square, 1 z terms get cancelled. x1 of z is equal to a z inverse whole divided by 1 minus a z inverse its whole square. Okay, this we got. Then what is x2 of z? x2 of z is equal to x1, that is we have expressed here in terms of x1 of n, that is x1 of 1 by z, that is x1 of 1 by z. Okay, in this you replace z by 1 by z, you'll get that is x2 of z is equal to, this is 1 by z whole inverse, it will become z, that is az divided by 1 minus az its whole square. Now final answer x of z is equal to how x1 of z, x1 of z plus x2 of z, you will get x of z is equal to, that is az inverse divided by 1 minus az inverse plus az divided by 1 minus az its whole square. So again you can take LCM here, that is 1 minus az inverse, sorry, this is also whole square, az inverse divided by this one here. Okay, now x1 of z is az inverse divided by 1 minus az inverse whole square, x2 of z is az divided by 1 minus az whole square, that is 1 minus az inverse its whole square, that is we get 1 minus az its whole square into az inverse plus az into 1 minus az inverse its whole square. Hence this completes the problem. This is the x of z.